Hello there. Today we're going to do the gender for today. Yes, we're going to do 3D. Okay, so our gender is. We're going to look into 3D Mohr circle. And then we're going to do combined loading. Of a beam. Structure. To determine the principal stress. Okay. So as you know, all structures are loaded in 3 dimension in the real world. Okay, it's not just 2 dimension. So how do we analyze a structure in 3D using 3D Mohr circle, and how do we actually select materials, okay, under combined loading. Combined loading down here means normal stress and shear stress. So let's look into 3D Mohr circle. So now the element will become a cube. Okay, so we're going to construct a cube now. So again, transformation still the same. So this is x, y, and where this direction is our z. So we're going to sketch out a cube. Okay, so this is our cube. Alright, so this is our cube, and then our cube with these surfaces. Okay, right. So we know that in this direction, this is our stress x. This direction, this is our stress y. And at this particular direction that we're going to have, this is our stress z. Right? And as you can see down here, over here, this is known as our xy plane, right? And then this is our yz plane. You better write in capitals, yz plane. And this will be our xz plane. And I'll call our xy plane as in plane, and our yz is out of plane, and finally our xz is also out of plane. So what determines what is in plane and what is our plane? Okay, so it's very simple. So the plane with the largest surface area is the in plane. Okay, so you can see the xy plane has the largest surface area, so we address that as in plane. Okay, don't laugh at it. Okay, it's how they define. So if we have another element, another cube now. Okay, so let's say we have another cube. So now the cube looks like this. Okay, so this is how our cube will look like now. Okay, so our cube is so-called oriented in this direction now. As you can see, I think some of you know where I'm heading with this now, right? So this is our cube. So again, this will be our stress X. Over here, stress Y. And over here, our stress Z. So we know based on 3D, this is our XZ plane. And this will be our XY plane. And finally, this is our XZ plane. So the one with the largest surface area, so this is our in plane. And this is our out of plane. And this is also our out of plane. Okay, so now we are clear now, okay, which is in plane. Alright, so we're gonna look at 3 conditions. Yeah, we're going to look at 3 conditions. So condition number 1, is where stress Z is equal to 0. Okay, stress X is larger than stress Y, and both are positive. Okay, so all our condition, I'm going to comply to this element, which I'm going to copy. Okay, and paste over here, and we're going to sketch this condition now. Okay, we're going to sketch this condition where it states that X is greater than Y and Z is equal to 0. Okay, so we're going to sketch our first 3D Mohr circle. So you realize that they are all without shearing stress at all, as you can see. So this is our normal stress. Then this is our shearing stress. Okay, clockwise rotation, anti-clockwise rotation, and then we declare that, I'm going to make this longer so I can draw better. So we declare that the normal stress X is greater than stress Y. So this is our stress X line. Okay, both are positive, so this is 0. So this is stress X, and then we are going to have a stress Y. Okay, so this is our stress Y. Okay, and then this is our stress Z line. So as usual, we're going to label this our point X, point Y, and this is our point Z. So this is over there, that's 0 shear, point X, point Y, and point Z. Okay, then we can construct our first circle now, right? So our first circle is over here. So this circle that we have just drawn is XY. So this happened to be for the XY plane, right? Because it's touching the diameter of the circle is like XY. Then we can draw another circle. And this circle is over here, right? So you can see over here now, this corresponds to our YZ plane, because the extreme points touches point Y and point Z. And the final one, the bigger circle, the third circle, okay, so 3, and this is the largest circle. I think I got it wrong. I think it's 3.5. Yep, so this is our final circle. Alright, so this belongs to the, it touches Z and X, so this belongs to the Z plane. Okay, so what we can see down here now, okay, what we can see down here now is this height over here that I'm drawing now, right? This corresponds to our shear XY max, which is equal to our shear YX max, right? YXY because it's on the XY plane. Okay, and this is our in plane, right? Remember I told you guys that this is our in plane, right? The bigger surface area, right? The in plane. So this is our in plane. And the next one, we have over here, you can see for yourself now, this corresponds to your tau YZ max. Alright, and we also know that this is your out of plane. And for this situation over here, alright, that's where you have to be, we have to be really cautious, is that this height now that I'm drawing the line, right? So over here, this height is our shear XZ max, which is equal to a shear ZX max, and this is our tau max, our maximum, because it is the bigger circle and it happened to be out of plane, right? So when this element is loaded, the shearing stress maximum is on the XZ plane, so this plane, okay, will experience the maximum shear. So we have to be really cautious with this, okay, because if you don't check, we always assume that the in plane will always be the largest. No, sometimes it can be our what? Our out of plane. So in this context, we can write down that tau max will be equal to the shear XZ max and is equal to shear ZX max, right? And this corresponds to stress X, right, plus by 0 divided by 2, okay, because over here this is a stress X, stress Z is 0, and divided by 2, and you realize that this is your what? Out of plane. Then I'm going to label this point over here to be my stress max, and then this point over here to be our stress mean. So we know that stress max corresponds to our stress X, and stress mean corresponds to our stress Z. Okay, and stress mean for this case is equal to 0. So that's condition number 1. So we're going to go for condition number 2 now. Okay, so I'm going to stop here first. I'm going to come back. We're going to talk about condition number 2. Okay, thank you.